The arbor vitae name means tree of life, and we're talking in the cerebellum at these white tracks. You see them? If you use your imagination, you can think of it as a trunk and branches on a tree. And that's the tree of life they're talking about. Do you guys see what I'm talking about? I'm going to turn around for y'all. But trunk and branches coming off, that's your arbor vitae. Good? All right, so it's inside your cerebellum. This is our cerebellum. I should go back to the pointy thing. So this would be our cerebellum. Good? You guys got it? Talking this right here. Okay, next. What we're talking about is this right here is all cerebrum. And that's from fetally from the from the telencephalon. You heard that before? Then when we get to upper midbrain stuff here, it's the diencephalon, and the lower was the telencephalon. Do you guys remember that? So I should do it with something less big, less like my giant finger. So this would be this would be tela, but mesa, but all this stuff here, this tela on the outside, this cerebrum, that's where all the wrinkles are. Now you can't see the wrinkles very well here, the gyri and the sulci, because you have dura on top. You see the dura? In fact, if we look, this is going to be pia, and I say that just because this is going to be arachnoid. It's definitely not. See how I just accidentally poked a hole? So I was like, how tough is it? So it's definitely not the dura, and it's definitely not following every groove all the way down. So like there, it's not going in the lateral sulcus. You see that? So I'm going to say this is arachnoid. Does that make sense to y'all? Good? Okay. They're saying all the wrinkles, gyri, sulci, the big part, this is the cerebrum. Even a sheep, which is kind of a stupid animal. Okay? It means the four bodies. They're basically four lumps that we're looking at. So I'm going to show you. God, that is good. Look at her pinhole. Anyway, I'm going to show you right here. So we pull the cerebellum away from the cerebrum. Let's do the other side. That cut was.
It's callosum.
Okay, this is the bridge between the hemispheres. Do you remember that? Okay. This, if you remember the Elvis chicken, this is the hairdo on the Elvis chicken. Comes up and curves. Now, on a sheep's brain, we already said the spinal cord is, instead of coming down, it's lifted up. The cerebrum is in the same place, but the cerebellum is up. Then everything, cerebrum included, is squashed flat. So I'm going to show you where the hair on the Elvis chicken is, but it's going to be a lot flatter than in our brain model. For a reminder, let's pick up a brain model. For corpus callosum, I'm talking about this curve right here. You with me? Let me point with this. I'm talking about this curve right here. That'll be the hair of the Elvis chicken. You good? Everybody good? This curve thing right here. Commiseral fibers that are where they come together. Does this make sense to y'all? Good? Yeah, okay. Now let's look at it on a sheep brain, which we already said is squashed flatter. So right here, I'm going to flip to the other side. That cuts a little off center. It looks even less like normal. Here, this is the septum pellucidum, and this is the curved white track of the corpus callosum over the septum pellucidum. You see it? Yeah? Okay. Here is our septum pellucidum, and here's that curve of the corpus callosum above it. Here's our septum pellucidum and the curve of the corpus callosum that's above it. Does this make sense? Yeah. Hey, anybody know if I punch my pointer through the septum pellucidum, what would be on the other side? Louder?
Death.
Not bad. Lateral ventricle, one of the lateral ventricles. Let me show you the half that I put over here. It cuts a little off center. Here is the lateral ventricle. I am now in the lateral ventricle. You see it? The other side, you can still see the stuff. Okay, again, I'm going to do it here. This is our thalamus, our bird's cheek. Good. Wrapping around it is the hippocampus, the skinny tadpole looking thing, and wrapping around the top of that bird head is right here. This is going to be fornix. So the septum pellucidum is between the corpus callosum and the fornix. Are you with me? Okay. Yeah. You see a lump and a lump right here. On our brain models, they're much smaller. What I'm dealing with is a superior and an inferior one. The separation being right there between the two. Do you guys see that? Yes? Or you see that? Okay. You got frontal plane. We are now looking at the frontal lobe. This is the frontal lobe right here. Okay, so occipital will be back here, frontal is here. I'm going to turn this around. This is the cut she made that I was like, oh my God. This is our corpus callosum. It looks like a shallow V when you're looking from the front. These are our two lateral ventricles. This is our septum pellucidum, our pallid or white color septum. The bottom of that septum is fornix. You see it? Okay. All right. Hard to spot here because it's so much flat. We will try. It would probably be about right there because this is our thalamus, our cheek of the bird. But I'll show you a way that you can see it really, really well. Fourth ventricle, you won't see in that cut, obviously. Or that, let's go here. This one, you see, we've already talked about the cerebellum. We talked about the arbor vitae. Go to the bottom of the arbor vitae. And here is a roughly triangular hole. Of course, I just stabbed, but do you see the hole right there? That is your fourth ventricle. That's one of the two places where we make cerebrospinal fluid. There is a choroid plexus at the back side, the posterior side, and also be more posterior and inferior because everything's bent that way. But there is, separate there. I can do it without poking and scraping. Do you see callosum? It is the roof above the two lateral ventricles. Right there, right there. Are we good? See where they took the knife and whoosh, that's your longitudinal fissure. Separates the two hemispheres. Not just the two hemispheres of the cerebrum, also the two hemispheres of the cerebellum. Good? The cerebellum has two hemispheres, and each hemisphere has two lobes, an anterior and a posterior. We'll talk about that soon. Are we good so far? Okay. To do that, we're going to first find where I put my stupid poker. Or we will be poking. There we go. That was literally by feel. Okay. What I want to point out first is we'll do this on the brain model, and then we'll do it. Here at the brain, we're very close to the spinal cord. This is the lower brainstem. There's an oval here called the pons. What's just below it, anything that's wider than the spinal cord that's below the pons or just a little in back of the pons, this is medulla oblongata. Are we good? Yeah? Okay. So pons is taking this and pulling it like that. So, and then flattening the brain. So let's take this and look again. And what you're going to see is our pons. There clearly is a widened area where there's a pons, but it's not a pretty oval anymore. This flat area that's rounded on the top and rounded on the bottom, rounded at the ends, this is the pons. And the medulla is still what's in back of it and tapering down to the spinal cord. Does that make sense? Could you guys, you got the pons. What's the next thing?
Dura mater.
Okay, we've got one of these that is super. I already pestered someone, made them do it. If you push, this is tough. How tough? That dura does not tear. The entire brain is being lifted by that dura. Do we agree? It's the outermost of the three layers, and it is tough. You can probably hear the paper clip going clunk, clunk, clunk. Yeah, this is it, right? Okay, we're going to do this like we were doing the other things. I'm going to first pick this up. Here is a human brain size model. You would agree? Might even be a little bit oversized. This would be an olfactory tract, and that would be an olfactory bulb on the end of it. First cranial nerve. You see it? See how narrow it is? Everybody sees this, yeah? Talking this right here. Olfactory bulb. Good. Would you consider this sheep brain to be larger or smaller? And it was like kindergarten questions. Would you agree the sheep brain's a hell of a lot smaller? Okay. Look how much thicker the olfactory bulb is on this little tiny brain. You see that? It's about double the thickness on the model. Do you agree? Why? Because they have to be able to smell the predator and run away to stay alive. So sense of smell really important to a sheep. Good? Didn't help this one, but you get the idea. All right. See, it says 2, Roman numeral 2. That's because this is a cut off piece of the optic nerve. The optic nerve will be going like that forward to an eyeball about here. Does that make sense? And then, it's easier to see on this side. So here's optic nerve, and where the two optic nerves come together, if I can get this assembled. Come on. So now we're looking at 2, the same thing. This is a pituitary that's very in the way and annoying me at the moment. We should be thankful that model's good enough to have pituitaries. There's an optic nerve. There's an optic nerve, and you see where they crossed over, yeah? That crossover is the optic chiasma. All right, so.
Optic nerve.
Okay, we're going to do optic nerve and optic chiasma together. So we're going to take this. We already looked at the olfactory. Here, where the whole Elvis chicken thing I've been talking about. Let's open this up. Let's remember what I said before, that we have the thalamus, which is the cheek of the bird. We have the hypothalamus, which is the beak of the bird. Coming off the beak, there were 2 things. Coming off by the upper beak, we had the optic chiasma. You see it? You see it? You see it? Okay. And then coming by the lower beak, we had the cherry-looking thing. That's your pituitary. The stalk, the stem of the cherry is the infundibulum, the stalk of the pituitary. Are we good? Does that make sense? All right, what's our next thing? Oh, well, we did that, but let's do it again. Would you agree we have a nice oval here for the pons? If you turn it back and forth, you actually see in the glint, you can see the line right here. I'm sorry, right there. That's the oval of the pons. We have this very flattened oval that is the pons in the sheep. Good? Yep. Okay. Everything that's tapering is medulla, so the spinal cord on this model would be below it. Good. Everybody good with that? So, what about on a real brain? We'll do it from the outside first, then the inside. Would you agree that it starts flaring, start getting bigger, cone-shaped right about here? Everything that side would be spinal cord. Everything here and here coming up to the level of the pons and squeeze between the pons and the cerebellum would be the medulla. Spinal cord is what's posterior to that. Good? Of the bird. Here we've got the cheek of the bird. With the eye of the bird is the interthalamic adhesion. So here's our thalamus right there. The 2 sides of the thalamus, in between them is our 3rd ventricle. Okay? So if we look here, do you see this circle right there? That's going to be your cheek of the bird. That's going to be your thalamus. And right here, we'd have the taper of the hypothalamus. Good? Yep. Okay, that's going to be something that'd be easier to see here if we use these. But we're not going to. This, I already told you, is an amazing cut. So right here, we have a lateral ventricle. Here we have a lateral ventricle. Though we have a little piece of the one in the middle. The opening in the middle here is the 3rd ventricle. You see it? It's a really good cut. So there's our lateral ventricle, third ventricle, below into the middle.